We're going to begin learning how to solve some simple equations. The simple equations we're going to start with are called linear equations. Linear equations have a form that we'll start to recognize that is some ax plus b equals c, where a, b, and c are numbers that we're familiar with, like 6 or -2 or 14. And we also want to make sure that this first a is not 0, because if it were a 0, then we would just have b equals c, and well, that doesn't mean much fun for us right now. Now you also notice that these are solutions that satisfy this equation, and it satisfies something that we're calling a linear equation. And here's this word line that's in that, which means that later we're going to be able to graph these out or create a picture of all the solutions to make this true, and they're going to form a line on a graph. And so we'll explore that down the road as we get closer. So some examples of what a linear equation might look like. We might have maybe a 3x plus a 7 equals a 14. That's a linear equation. Maybe I'll have just simply minus 15x equals 45. That's a linear equation. It satisfies this form, but maybe this one b is 0. So I'm just left with the ax term. Likewise, I might just have simply x equals maybe 6.8. So all of those represent a linear equation or an equation in linear form. Maybe opposed to where something that may not represent something, 3x squared plus 7 equals 9. That's not of this form because when I look at the x term is squared. And so that produces something we call non-linear. And we'll discover those down the road, and we're developing the tools that we can solve those as well. But we're going to wait for those down the road. Maybe we're going to get something like a fraction with a variable in it. Call that a rational expression. That's also a non-linear expression. And then maybe, and there's lots of them, but maybe like an absolute value of x equals 6.8. That also produces something that we call a nonlinear equation. So as we explore through this section, we're going to explore things in the form of a linear equation, and not right now the nonlinears. So we're going to develop a couple of simple rules to help us figure out, well, how do we solve something like this? What do we do?